this year we really wanted to focus on system engineering in this conference. And a glaring omission on the previous program was activities and talks and material around the metrics workshop. So it's like, who can we ask in the industry to kind of help us kick off this activity and get it started? What we didn't realize is that we would run across Brendan that would just put it in high gear. It's I don't know. He will have to talk to his outfit himself, but it's like your little tricycle, and then you have your big rocket. So we feel very fortunate that Brendan stepped up, and we have Theo here, we have Cascade, Peter Nordhaus is here, so I think it's going to be a fun day. If you want to take it from there, that's where it goes.
Great, thanks Kent, and thanks for showing up. And I can put this microphone on if people can't hear me properly, but I think since the point of this day is for us all to discuss and have a constructive arguments, it might be easier if we don't go with a mic, so we can all speak up. So, as Ken said, this day is a metrics workshop, and we know we have some great people in the room. There's a lot of you we don't know, and it's going to be fun finding out your background, the problems you have, the ideas you have. What I'm looking forward to most today is hearing from you about what metrics work and what we can fix. So this is about discussing and figuring things out together. I have some light framework slides that I can talk from. However, as I said, most of this day is going to be a discussion. Kent mentioned, why am I dressed like this? At the end of the Surge conference, Theo, who's sitting over there, gave a talk about how we can be better engineers when it comes to things like modeling. And the discussion at the time happened to be about the 1960s NASA technicians and engineers. In fact, I have a picture of them. And it's not a great picture of diversity, I have to admit that. But it was something to aspire to in the problems aren't too hard. We've put men on the moon, and yet here we are in IT. We're not fantastic at metrics, at modeling, at really putting science into what we do. And it's something that hopefully we can start today, especially when it comes to metrics, is taking on some of the harder challenges and working on that. So, I will start with a quick introduction, and then what I want to do is we will quickly find out who's in the room and people's background. And then during the day, it will be more discussion and more lightly guided conversation. So the format, there will be 4 major topics, and these slides are just reminders. The 4 major topics: an introduction, especially about metrics, and then I will lead a talk on metrics and the audiences, the served goals, posing questions, methodologies and ideal metrics. And something really exciting that we can, do we have a board we can write on? I guess I can do it on my laptop. Oh wow, excellent. So something I'm excited about is we can come up with some ideal metrics that we'd like to see measured, and then document that and share that with the community. And so, talking about actually designing the metrics. There's quite a lot of making do with what the operating system gives you or what the application gives you, and this is an opportunity for us as a group to figure out what we really want. Implementation. And so for this section, it's all about putting it together. How do you collect the metrics, present the metrics, aggregate them, provide a service for accessing the metrics that's reliable. This is similar to there's been many blog posts, talks about the concept of monitoring sucks. So this has some parallels there, and that's actually a useful way of understanding, of admitting that we have a problem and working on defining the problem and then looking at solutions. The last section, analysis, is a crash course into statistics, which I'm looking for a volunteer to do, but I can do this myself, and visualizations, which different visualizations are effective at presenting metrics. 4 sections, and believe me, today is going to fly. We've had a few planning sessions where we've talked about what we'd like to discuss, and it's all fascinating content, and hours can tick by very quickly. So I will not waste time and just get on with it. For the introduction, I will, in a moment, stop and ask who you are, but let's get to that point. So I would like to talk about the aims and the problems, the vision and the community, background of how metrics really work, and then this is where we can get into discussing. It's just part of the introduction, what metrics work and what metrics don't. Typical OS-based metrics. And it can be useful, of course, to have some venting of anger so that we can understand the problems you've had. So to start with, why are we here? Why are we doing metrics and why are we doing monitoring? Kasky had a great summary that he's been working on for understanding monitoring, where, and I've added one, this is, we're providing metrics for operational health. And so that I will respond to an alert that my environment has a problem. Quality assurance, SLA, it's a different set of needs, but it's also something that requires metrics. Capacity planning, of course. Product management. See, when I was copying and pasting the slides, I didn't...
If you want to find out what the magic letters mean, come to my talk tomorrow.
Kasky's giving a talk tomorrow. We'll go through this in more detail, which is great.
Nauseating detail.
No, not nauseating detail, great details. It's great to study this this is part of why we're here. But, and then performance analysis hypothesis testing, this is where instead of responding to an alert or a trigger or what the system has told me is a problem, I already think I have a problem from another source, and I'm using the monitoring and the metrics to test hypotheses. So it becomes a tool that I'm using to debug problems. In the introduction section, I wanted to talk about the aim of what do we want metrics to provide. Metrics should be effective at solving problems. It's very easy just to add metrics because this might be useful one day. I used to work as a kernel engineer. I still do kernel engineering, and it's very easy just to decorate the kernel with all sorts of statistics. But once you do that, it adds to the complexity. There can be too many statistics for the end users to wade through without some way for them to navigate. This becomes a maintenance burden. And so we would always, when an engineer was proposing to add statistics to the kernel, is what problems is this going to solve? It's very important to keep that in mind. Also, as easy and intuitive as possible, there are many metrics which require the end user to study in detail, understand various parts of the kernel internals or application internals. Sometimes that's necessary and it's unavoidable, but we would like that to be as simple to reach a wide audience. And I have discussed here, is there anything we've missed here? Just at a high level, what metrics should be? Yes?
I think there's been a lot of focus. When people look at this, they end up collecting metrics and they start from a systems level, and then they worry about going too detailed. Whereas when you look at the metrics that most companies make decisions on, they forget they have systems at all, or networks. Those metrics are KPIs and business level, their sales, their pipeline management, all of those things. And those metrics, to the idea of going too deep, being concerned because they're not accessible, I think that is not a collection problem, it's a presentation problem. And that as a kernel engineer, there's always going to be something that you need to see that someone else as a JavaScript engineer not have a clue what it means, right?
Right.
So you can go deeper. The question is how to separate those out, how to make some sync and some float, so that when someone else comes in, they can see broadly applicable metrics. But you, when you see a specific problem, you have the depth. You can go down deeper. And when you step back from a business level, one of the problems that we have is we have all this systems telemetry. And classic problem, right? You have a web page slow down, or you have a database transaction slow down, and everyone freaks out. Well, why did they freak out if no business was harmed, if no user was harmed, right? So if you can't tie that back to something that like the entire infrastructure is actually supposed to deliver, then you lose perspective on the problem, and you make poor priority decisions as well. So stepping back, the same argument, but even stepping back further in a business macro level.
Yes, that's a good point. And I guess to put a bit more detail on the problem, it's where the kernels provide tens of thousands of metrics, and we're concerned about what are the specific audiences exposed to, and it's a navigation problem. And how do we expose that to them so that it's easy for them to pick up, whether they're interested in those business metrics or whether they're system administrator and interested in this set of metrics and so on. And we've got problems are starting to be written up, so...
It just struck me when you said that, like, someone needs to write that down. Yeah, there's a lot that sucks about it. I want to capture this so we can discuss it further.
Are there similar problems there to the same way that APIs has a surface area, that if you mix and match really granular APIs with like high-level APIs, you have a problem. Like when you say business data and KPIs on that, those are many times aggregates that goes out. Like would you worry about them being mixed up with very granular funnel data, for example?
I think the mixing is actually, you don't want them accidentally mixed up.
Right.
You don't want them in the way, but I think the mixing is actually a huge opportunity.
Right. And Cassie actually talked to this yesterday when we did planning. Like in your method, you are mixing both.
I see this as not really a dichotomy, but as a spectrum, because usually your KPIs are somehow derived from this. So you have many metrics at the system level and the application level that you're gathering, and somehow you're distilling down and synthesizing that. And there's this reduction of diversity, but then somehow turns into we have more users today than we had yesterday, or 7-day actives are up or down, and what I'm trying to figure out is are these two different forces, or is this just another way of looking at the same thing, but with less of the same, I don't say thing, but less of the same, element.
I mean, ideally, every telemetry point, no matter how low it is, has some impact, some non-zero impact on some business KPI. If it doesn't, you would turn the machine off. The short answer to that is you would turn. If the business doesn't need to deliver a service that system provides, then the system is pointless. It's a waste.
Okay. Yeah.
And you can push that up and say, hey, guess what? We don't have the right KPIs, which a lot of people don't. They have KPIs that don't really represent what's needed. But that's a highly iterative process. To me, they're all. It is absolutely a spectrum, but they're all very, very interrelated.
So that's talking about metrics. In later parts today, we do want to discuss gathering, reporting, analysis, visualization, and what those components should be. The problems with metrics, and we've already discussed some of this already. So missing metrics, it's important to be aware that there are many metrics that the operating system doesn't provide, that applications don't provide. It's easy to assume that the application developer is much smarter than you are, the kernel developer is much smarter than you are, and if there's anything that could be useful, they would already have provided it. Having worked as application engineers and kernel engineer, there's huge blind spots throughout these code bases I've worked on. And yes, there are missing metrics. Just to give you one example, I work on Linux a lot these days. I used to work on Solaris a lot. Solaris didn't provide an easy way to see network throughput. So how busy are my network interfaces? It seems kind of ridiculous. It's one of the most standard metrics you want to look at in an operating system, and it was kind of painful to actually get it out. and to figure out network interface port utilization in each direction. Confusing metrics. I mentioned that already. We'd like metrics to be as simple as they practically can be, so it's not too much effort for people to learn. Exposure of many metrics, and as Thea mentioned, this can be more of a navigation problem. How do you present them to newcomers? People have different audiences and needs, as Kasky wrote up, and so each of these people, how do we expose the metrics that they need as simply as possible? I put a question, what metrics should a sysadmin learn? And just to think about it, the systems and applications have thousands of metrics. Do we want system administrators to learn 20 metrics, 200 metrics, 2,000 metrics? I still do teach system administrators, and I'm always reminded about how limited their time is to learn all this stuff. And so I've helped author very thick books on kernel internals and performance, but people's times are limited. So I actually think there's a finite number where a system administrator may only have time, really, to learn 50 metrics, and that's it. And so we want to make sure that those 50 metrics that they will actually go and learn and understand properly provide the most value. And this is why I would argue when people talk about, let's just add this metric, it might be useful one day. It's how do you add it? Are you exposing it to people? Are you forcing people to learn it? If anyone's read it, I like the function complexity ratio in the Mythical Man Month about how as more function was added to computers, this came at the cost of much more complexity. And it may actually make computers harder to use. And so the author thought about the idea of having a ratio of function over complexity. We can add more function, but be aware of how much complexity it's adding at the same time to the end user. Poor documentation. If I'm a kernel engineer and I'm writing a metric, then documentation may be seen as a tax on my time. Often as a kernel engineer, I'm adding a project because I need to add support for this device driver, I need to add this new feature into ZFS or whatever it is, and I'm gold on closing that ticket and then doing the push. And other topics like adding all the documentation for it, adding the metrics for it can sometimes be seen as a tax, and sometimes these can be done in a hurry. And so there are many cases where metrics aren't documented very well, and documentation becomes stale over time as different code parts are added and as software evolves. Basically, metrics sucks. There's an interesting movement called monitoring sucks that I'm sure a lot of you have heard of, which is interesting because it gives a name for something, and that is about, well, we'll talk in part 3 about the gathering and presentation, all the tools you use to have a stack for doing metrics. It gives a name for it. It helps the community define the problem and then work on solutions to the problem. And I do think there is a problem with metrics sucks, especially when I see customer environments and they're monitoring a subset of metrics very, very well. However, I know that there's certain classes of problems they can't attack at all because they don't have those metrics on hand. Their application doesn't provide them, their system doesn't provide them. This is what we can talk about today. And that's the vision for the community. Admit we have a problem, study the problem and propose solutions, and to develop standard ideal metrics for different services, which we'll try to do today, and to serve the aim. And at the end of today, what we work on and what metrics we decide are important, what stack architectures, a standard stack architecture for gathering metrics, whatever the outcomes we can share. I'm not sure we should share it under metrics sucks, but this is something that us as a group can share with the community. So metrics background, and I want to get into who have got in the room, which is the next slide. So I put a few bullet points just before we start the more of a group discussion. How do metrics really work? and especially operating system metrics. I spend a lot of my time in operating system metrics. Now, you will see, when I describe these, I'll often go and use SAR, or I'll go and use operating system tools. And you may say, but I'm using a graphical user interface to access this. I don't care about these operating system tools. So if during today, I do various tool-based demos. And the reason is they're sourcing the same metrics. So if I'm on Linux, the metrics come out as /proc and /sys, and various other accounting mechanisms I can enable. If I'm on other operating systems, it's a similar story. There is a common source of metrics that either the command line tools source, that SAR sources, and then your graphical user interfaces, the monitoring software you use, typically sources similar or the same statistics as well. So understanding how those statistics work is important. I put an item to diff a kernel metric, and I was picking a couple of examples. Let's get up to. I'm going to have to change the. Let me open up a new terminal window. Okay, that's better. So I'll go through a couple, just a couple of different kernels. I was going to look at just as a quick example. This happens to be the Linux kernel, then I'll do an example of the Linux kernel. I looked at the Git history, and it's like, what's an example of a recent metric that was added? And Jerry Jelnick added K-stats to track reasons for fork failures. This is new to me. It was added August 21. And the greater point here is, go to the okay, it ends about there. It's not that much code to add statistics. In this example, we already have a struct which contains various miscellaneous things. He's gone and added some members for whether we've hit a resource control, different types of errors that might be interesting. Then those things are initialized, and so these are system-wide kernels. Kernel calls kstat named init, fork fail, fork no memory, and so on. There's a routine which sucks the kstats into memory so that the kernel can know when to refresh these. It doesn't have to do it all the time. It's when it's being requested from userland. And then adding these are just a few lines here and there which actually go to the metrics and then increment them. This is using an atomic add so that it doesn't require doing mutex locks, which would be expensive. So to be high performant, and that's it. So
there's pretty much no cost except the incrementing a value in memory and then deploying that through the system.
Right. So it depends on the type of metric. In terms of performance cost, you can see how in this example it's atomic add 32s, and they're very, very fast, and so we don't really worry about adding them. There is a maintenance cost because now that we've added the metric to the system, who's going to maintain it? And there's actually a big problem in, there's certainly a problem in the Solaris family of kernels, and to an extent in Linux as well, where how do you test metrics? Is it a supported interface to access various things that we have? Now it's something that was solved much more recently by DTrace. With DTrace dynamic tracing, it provides probes, arguments, actions, and into the language, it understands its own stability semantics. And so when we add a probe to DTrace or we add metrics to DTrace, it understands whether it's supposed to be stable for the end customer or whether it's an evolving interface or whether it's unstable and will never be stable. And as an engineer who's maintaining that code, I now know if I'm supposed to maintain these counters because customers depend upon them. There are also test suites for all of those stable counters because the actual kernel itself understands its own stability semantics for these metrics. And so that's a great model. Unfortunately, that model doesn't exist for these older metrics. So certainly in K-stats, there's no model inside here, and this has been discussed many times over the years, providing stability semantics to K-stat so that as engineers, when we're maintaining the code, we understand we're affecting a supported code path. And we need to add a test suite for this metric, and it needs to pass the tests. So that was just a quick example of looking at something. Yeah, it's the performance cost in this case is very low. It's just maintaining the code. Actually, when I've worked on these things, the most time it took for these metrics was not writing the code or maintaining the code. It was discussing what should it be, because we just don't want to waste end users' time with some half-baked metric. At least that's when it's done properly. When it's not done properly is when the engineer is in a hurry and I need to do this push by 5 p.m. tonight, and I forgot to add metrics to it, so I'll just add some very quickly. And when it's done properly, we actually spend a lot of time trying to decide what's best, which is what we want to do today. That was a Lumos example. Let's have a look at, what was I going to look at? Let's look at, so in the Linux kernel, I've just looked under, can't see my prompt of course, but under fsproc, and then uptime, it's nice and short. And so there's a kernel function proc create uptime, which will create the entry, and then go and use these ops. Proc open, and it has a routine for doing the uptime proc show, which goes and ultimately pulls it from uptime.tvsec kernel counters that are already maintained. So I was going to look at load averages. Very similar. Proc create load average. I've got a load average proc open function, and then it goes and fetches them from Avanrun. And what's interesting is then, well, where does that magic get updated? You can then look that up. Anyone use cscope? Wow, I have a few people saying yes. So then I can look up where is Avanrun actually updated. Okay, so it's updated. Oh no, that didn't work at all. Get Avanrun. Anyway, I can search through the kernel, find out the code paths that are updating that metric, and that's how it is exposed. So the kernel metrics themselves, not a big problem. I think the biggest problem is deciding what they are. Where I work, we're a cloud provider, and we change the kernel to suit our audience. And when I've decided we're missing a metric and I file a ticket, one of the people who are working on the kernel every single day add it very quickly. Because for them, the hardest part is deciding what it should be. It's not adding the metric itself. And the other thing I wanted to mention was, you may be looking at this and thinking, that's very nice, Brendan, but we don't change the kernel at work. We just use the Linux kernel. We're not going to be adding metrics. There are technologies now such that you can, if you think of metrics, you can then roll them dynamically and try them out. And so there is DTrace for a bunch of different operating systems. There is SystemTap for some versions of Linux. There is perf. Has anyone used perf dynamic tracing? No one. So has anyone used perf? Linux perf? Come on, some of you have used perf. How do you measure IPC? How do you measure, like I want to know if my CPU interconnects have an issue. How do you do that? Anyone? Yes. No, you weren't putting your hands up? So no one? Okay. So on Linux, there's, I'm expecting you to just tell me there's some tool I don't know that you're using that doesn't happen to be perf. Anyway, on Linux, there is this thing called perf. Perf's great, I like it. It actually does do some limited amount of dynamic tracing. The greater point is, with dynamic tracing, if you have an idea for a metric, you can put it into I hesitate to say production because these dynamic tracing things aren't fully finished on Linux. But the idea is you can put it into production straight away without requiring a kernel change. And so I can't tell you how many times I've done this, thousands of times, where I've come up with metrics and just implemented them in production without having to change the kernel to see how they work. And if they turn out to be really useful, then you can give that information back to the kernel engineer to make a change. And just to give you a demo of what the heck I'm talking about, I think it would be fun if I tried this on Linux. I think. It depends if I set this up. Let me find out. Just minimize some. So I'm on Ubuntu, and I have a demo version, a prototype version of the DTrace pod. And how do you currently see what file system calls are being made to ext3 or ext4 or Butterfast or whatever it is? What tool do I use in Linux? I just want to know, I want to do workload characterization of my file system workload. Is it heavy on get adders? Is it heavy, is it heavy on, thinking networking, is it heavy on doing statistics or get directory entries or doing opens and closes or doing synchronous writes? Very important. I want to characterize the workload that you're applying to the file system because that can help me make decisions on system architecture. Do you need to have certain types of disks to handle synchronous writes or not? Does it need to be battery-backed, flash, et cetera, et cetera? How do I characterize the workload to the file system? Linux. Did I pick the wrong? I can do this on a different operating. If no one cares about Linux, I can switch to something else.
I don't think that nobody cares about
Okay.
Linux. So I'll be the victim of this one. So the bad way to do it is you try to figure out which processes are doing lots of I/O. You can use strace to kind of get a sense of what's going on, and it's going to stop.
Right. That's a good point. So you can fire up strace. Strace is violent. It is a breakpoint-based tracer. It'll slow things down, but you'll get the information you need. And especially if I run it for a minute and I use strace with the summary statistics, then that's it. I now have characterized my workload. In this example, I'm just going to do it from DTrace. DTrace in mind. And so I've gone into the kernel and I've said instrument ext star. So now I have gone into kernel memory and I have live patched the Linux kernel and said each time you run one of these ext4 calls, bump a bean counter to let me know you hit it. I find what DTrace actually does is pretty much insane. The way it can live patch the kernel as you're running. This is like changing engines on an aircraft as you're flying, or doing maintenance, but it's allowed me to do a workload characterization at a very deep level, so I can see exactly the different calls that are happening. And of course I can do whatever I want. It's ext4 reader. Let's get timestamps out of it.
Are you doing completion there?
Sorry, what was that?
Did you just really type fast typing, or were you doing completion?
No, there's no completions.
Just checking. I was thinking, how the hell does it know what the system calls are?
He's not human.
What I'm actually going to do is this. So I'm actually typing on the Dvorak keyboard, so just as a plug for the Dvorak keyboard,
so if we give you a real keyboard, you'll slow down a little bit.
I think finding the keys is not the problem. It's knowing what you want to say.
Actually,
He likes to live life on difficulty mode,
That's
extreme.
One of the biggest problems with DTrace in general, though, is that DTrace DTrace can answer almost any question you can ask it, which you very quickly arrive that you don't understand what questions you need to ask. It requires a pretty intimate knowledge of how computers work, not just how operating systems run processes. So I think that from a lot of the sysadmins that I've worked with, even some that work at OmniTI, the understanding of how kernel code works, how C code works, how stacks work, all of that kind of stuff. If you don't have that, then you don't even have the language and the grammar to ask the questions that you want to ask. You sort of know what you want to know, but you just have no way to phrase that.
Right. And so as Thea said, in order to just dig into the kernel and pull out, answer questions, you do need to understand quite a lot of the kernel. It is complicated. I think practically, there will not be many people who actually cut DTrace scripts. Like, it would be great if more people did, but I don't think practically it's going to happen. But what we do want practically is for everyone to be aware that it can happen. Because if I'm at a company, you don't need everyone to write DTrace scripts. You just need one person to do it. Or you need one person in the community to do it. But you do need everyone to be liberated to ask the questions that can be answered. And that's why I gave you this demo right now, to liberate you. So I've just said ext4 read directory, store a timestamp on entry. On return, if I did the timestamp, give me nanoseconds latency for just this random kernel function. And now I have a histogram. I can use this for chasing down outliers. I can see where the bulk of the data is. If I want this done as a mean or standard deviation, I can do all that stuff too.
Can you recommend a good book for writing and learning DTrace?
Can I recommend a book? There is a good book, actually. I don't have a copy to wave around. So there is a book called DTrace, which I authored with Jim Merritt.
I would say our experience in having one person that knows how to craft DTrace scripts is insufficient. I mean, so for example, this is the histogram that you've just created for nanoseconds of delay from entry to exit of reader, right?
Yep.
That's interesting, but is that correct? What did it look like 10 minutes ago? We can't know that because you weren't running the script at that time. So when you have a problem, like DTrace seems incredibly useful for asking questions that became unexpected, right? Like, what is wrong with the system right now? So if there's something wrong with the system, you need to be able to ask that question, because then if you turn around and ask someone else and they're like, hold on, I'm writing a DTrace script for someone else, and they get back to you, that problem is no longer manifesting. So it's kind of like needing a translator to do a significant portion of your job at that point. So it's been a slow process, but ramping our engineers up in the ability to use DTrace has had crazy good rewards, because they need to just be able to ask the question.
That's a good point. As Thea said, it is crazy good when more people do pick it up and write it. At Joyent, just to share my experiences, we have engineers who can all DTrace, but we also have a support team, and they generally do different things. They're working on support tickets. And so what I do is I have a repository of DTrace scripts that I share with them, and they consume the DTrace scripts. And if they have a need, they keep seeing an issue, I will add a script to that repository so that they can then use it.
We ship clients DTrace scripts to debug stuff in production all the time. We don't run the machines for a lot of our clients, so they're somewhere else in the world and they're running some app somewhere. And of course, I don't know how many people have provided support for apps where you've shipped an app and they go, I'm seeing this behavior, and the first response from the application engineer is, well, that's not possible. It's like, well, okay. So given that it's not possible, and it's, yes, I reject you, so what questions of the reality do you want to ask? What do you want to know about that? And you can actually codify that in DTrace, ship them a DTrace script, and then you get this fantastic log for this scenario that should never happen. And it's an incredibly useful troubleshooting and debugging tool.
Then you go back to the application developer and rub their nose in it.
Yeah.
Oh, see what you did, now fix it.
Empower them. Empower them to write the DTrace script yourself. I would say that's more effective.
Yeah, that's what I'm a manager.
Is there a repository of DTrace scripts that you could wander through and say, I use this for X?
There's yours.
There's a toolkit of DTrace scripts.
There is a toolkit called the DTrace toolkit. I've been working to get this on GitHub. It is still in progress. I was trying to work on that last night as well. So, but there is a collection of them, and a few people have these collections online of DTrace scripts.
I find that they're really useful tool for understanding how to structure a program and how to accomplish complex tasks, but not for asking questions. Because there's someone else's questions, it's someone else's problem. So basically it's a translator where you're like, I want to ask this question. What do I think, what DTrace script might ask a similar type of question? You go read it, see how they structured the code, and then you can kind of translate it.
I want to write code at least first.
Right.
Yeah, it's not so bad for Google to type DTrace and then thing you're after, and you'll generally find the scripts pretty quickly. But I am wanting to get this set up on GitHub properly so that people can contribute and we have a broader collection of scripts. I've been working to get that done.
But to Theo's point about historical data, where you ask a question when you see artifacts of a problem, and then like phrase a new question, do you also use DTrace to capture historical data? So do you run it all the time and just
Yes, like I previously did a analytics environment where DTrace was collecting latency histograms 24/7 by 365 at a 1 second granularity. And so you could go back in time years and then generate a heat map of latency data. So yeah, when DTrace is fully ported, and it's not there yet on Linux, it is on, if you're on FreeBSD or Mac OS X or Lumos. When DTrace is fully ported, it's production safe, it's just like any other tool, you use it. You want to run it 24/7, do it. And although the way DTrace works, it's not as cheap as adding a counter into the kernel. And so in the long term, if you're using these DTrace scripts all the time, then you need to ask, can the kernel engineer just add this so that I can stop running this DTrace script? The way DTrace works is it does jumps, and the way it dynamically patches the kernel instructions or the userland instructions. It's not as cheap as just adding a bean counter. So in the longer term, once you start using these things all the time, then bake them into the kernel. As the last example, just to give you an idea of what can be done. This is a boring demo because I don't have any retransmits happening on this Linux VM at the moment. But a common thing that we debug at my company is retransmits. Who are we retransmitting from and to? Why are we retransmitting? Are they timer-based retransmits? Are they fast retransmits? Is it because of duplicate act detection, et cetera, et cetera, et cetera? Helps you understand and figure out, do I have a network problem? Do I have a tunables problem? Do I have too much load for this system problem? And so this was a script I wrote for the Linux kernel where, you know what, if you retransmit in the kernel's doing that. The kernel knows it's retransmitting. And so it's got a function that runs, TCP retransmit SKB, and you can just dig out details. I want to see the destination address. I want to see when this happened. I want to see the stack backtrace, because the stack backtrace will tell me if I got here through a timer, because it's a timer-based retransmit, or if I got here through a different code path. So again, it's posing arbitrary questions and then just getting the kernel to answer it. And I tend to use this so often, it's almost at the point where it's like, do I need to be using DTrace for this? Can't we just have a tool that gives it to us? Actually, maybe that one will be DTrace forever. So as metrics background, I just wanted to show adding metrics to the kernel, really not hard, it's just lines of code. The biggest problem is deciding what makes sense. And then we have this thing called dynamic tracing. You may use DTrace, you may use perf events, you may use system tap, you may use something else. There's KTAP now, there's LTTNG. I'm sure there'll be another one next year. Lots of different ways to do it where you can prototype metrics for both applications and user level. That's a quick introduction. Now, at this point, what I'd like to do is have a few examples of things that work and things that don't work. I'll give a couple, but then this will be a good time to go around the room, find out who we've got, and you may just tell us who you are, why you're here, what you hope to learn from today. But if you also have a neat, short example of, I used this metric and I thought it was great, or I used this metric and it sucked, and this is why it sucked, that could be useful for us to use when we're deciding the ideal metrics later today and how to present and report them. So, think about that. Or instead of talking about a metric that sucked or a metric that worked, you might want to talk about a project you're doing at work where you're building a stack for monitoring metrics. It might be interesting as well. I should also say, at any point today you may have, since we have a lot of people who are fascinated with metrics in one room, you may say, well actually, I want to share with this team this cool project that I'm working on where we are building this infrastructure so that I can get constructive feedback from the experts here. So if you have that idea as well, let me know, and then during today you can stand up and present the thing that you're building with metrics, and then we can give you some live productive feedback if that sounds good. But to start with, what I'll do is I'll just pick a couple of these to talk about, just very, very briefly, like a couple of minutes, to give you an idea of how to phrase whether something's good or bad. And then we will go around and find out who we've got, and I want to hear from you what works and what doesn't. So, what should I pick on? I'll pick on device utilization. So, device utilization, it's often presented as a % busy, and the term utilization itself is misleading. So, in some definitions, utilization is the time during an interval which that component was busy actively performing work. By a different definition, utilization is the capacity used for the target. Now, these are different. For example, for a disk with % busy of a disk, you may expect once it gets to 100%, the disk can no longer accept any more work. And any additional I/O sent to the disk is going to queue. We call that saturation, and performance will go downhill rapidly. That's the capacity-based definition of utilization. The other definition, which is time-based, is really the metric you're looking at. And so, device utilization, I like it, but I only like it because I understand how operating systems typically provide this, and they're providing it as a time-based. It can get really, really out of whack. So if it's providing a device utilization, and that turns out to be a hardware RAID card, which is giving me a virtual disk, there may be many, many disks backed by it. You can get to 100% utilization, but the disks are mostly idle. There just happens to be something active. And so that can accept much, 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 much more work. So, device utilization. It is confusing. Maybe we should be calling this % busy all the time. IOStat calls it %B for % busy. When at my company we worked on a monitoring product, and Dave Pacheco, I was explaining to him utilization and why it's confusing for the end user, and he really didn't like it either, and so he came up with the idea of calling it non-idle time. So instead of calling it % busy, you call it % non-idle time. I'm not sure that's going to catch on, but actually that's really an accurate description of what the operating system typically provides. So device utilization, it's the other thing I want to mention about device utilization, which is annoying, is that on a per device level, I can interpret that fine. So once a disk gets to 100% or a CPU gets to 100%, that typically will enter the saturation zone, and then you've got performance issues. And I can use queuing theory to find out at what percentage point does my mean latency double and my 99th percentile get worse, and so on. But a big problem with device utilization is that many monitoring products present this as a average across many devices. And so, average % CPU, maybe that's the metric I wanted to discuss. Average % CPU. Really don't like this metric. It's okay to see general trending of a server. So I don't want to never see it. Sometimes that's useful. But for CPU, there are many issues where you have a single CPU that hits 100% utilization, 100% busy, it's maxed out. or I have an imbalance of CPU utilization, and the same goes for disks. It's taking multiple components and then showing me their average across all of them that I find to be really problematic. Doesn't help me solve the problems I'm trying to solve. So for device utilization, I want to see it per device. That might be a histogram. If you're doing that over time, that might be a heat map or some other visualization. So that's an example of a metric. Useful, but with caveats. It is actually percent busy, which is not as clear as you'd think. And I do need to see it per device.